Hello student, this is the part 4 where we are going to cover the doubly linked list, and it is from the chapter 2, that is linear data structure. My name is Drashti Mori and I am from the new LJ Institute of Engineering and Technology University. These are the contents we are going to cover in this video lecture, that is doubly linked list, then after operation of insertion as well as one operation, that is deletion. I hope we are going to enjoy our video lecture. Doubly linked list work. When I say doubly linked list is what? It have the two pointer, one pointer pointing to the previous node and one pointer pointing to the next node. Here I write left pointer and right pointer. Is this fine? And what would be here? What would be the left pointer pointed by node 1? Node 1 don't have any node, so it will point to the null. Fine or not? And what is this? This is the representation. It is one example where doubly linked list can work. In a playlist, you have full flexibility that you can reverse, you can forward, in both the direction you can move. So this is one logical representation of your doubly linked list. Right? Now let me introduce you one operation that is insertion. Yes, when I say insertion means you want to insert something in your linked list. And where should I insert? One memory address is given, that is M. So M is the location and you have to insert something in left of that M location. Here you don't have to traverse because memory address has already been given. So you have power of two type of link. Yes or no? So in our case, they said we have to insert some new node left to the 106. So here 106 is here. Yes. And you want to insert something in left part of that. So what would be my final linked list? D, J or M is the original linked list and you want to insert in between. Yes. In our case, it is the case, but for general scenario, we want to write the algo. So you should be cover all type of probability. Yes. So you have to check different type of validation. So what thing you should check first? Check my linked list is empty or not. If it is empty, it is okay to insert something. Yes or no? For insertion, you don't have to check that linked list is empty or not because it is not the very prior condition which you should address. So we don't need to check that it is empty or not. So what will be the next step? We need to create a new node, and that new node, I'm taking any random number. Right now, I'm not checking the avail and all because it is itself very complicated topic. So we drop the part of avail pointer. So here new node get address from anywhere. In my case, I'm writing 10. Which number should I take? 104 is fine. So 104 is a new node location. So whatever I'm created, it would be updated here, right? And what they said, my new node would be created here. That info part would be with my X. X is a variable which have some character. Fine. Now check. In circular linked list, we have last and first pointer, but in doubly linked list, I am considering two pointer, which first pointer pointing to the left. Left means your first and R means your last. If I want to draw this in a diagrammatic form, it would look like this. It is L. It is my first. This is my second. And if it in the case that I only have two nodes, then it will point here. Yes. And this will point to null because it is my last node. Same way, it is a first node, so its left pointer is null. Fine. And it will point by here. So here two pointer are there. One is pointing to in this direction and one pointer pointing to in this direction. This is my node 1 and this is my node 2. So this is one pointer pointing to this node 1 and this right pointer is pointing to what? It is pointing to my node 2. Fine. So R is checking that it is null or not. In which scenario R would be null? In the case where linked list is empty. In a case when we only have one node. In this case also L and R will point to one node. Fine or not? So if someone says your L is null or R is null, in that case you are very sure that your doubly linked list is empty. Fine. So if it is a null, then what you can do? You update your left pointer. It is my new node, right? So new node left pointer and right pointer should be updated with what? Null. That is our new node at 104 and here our x. So in the case when you have only one node, your left and right pointer would be null. And your L and R would point to what? New, right? So your L and R should point to new in the case where it is the first node you are inserting. And we should return from the your algorithm. Now in a 4-step, we check that it is the leftmost insertion or not. Well, when you can say it is a leftmost insertion, if your L or M both are pointing to the same node. L is always point to the first node and M is also pointing to your first node. In that case, you can say that whatever insertion you require to do, it would be by become my first node. So if it would become my first node, which thing should I do? First, I update my L pointer. That L pointer need to be updated with 104. Then after what you can do? Then after what you can do? You also update your L pointer. Yes or no? That whatever the new node, that L part would be updated with null because it is my first node. In the case of leftmost insertion, it is my first node. There is one linked list, but whatever we are inserting, that become my first. So they have nothing to point as a left side. So L pointer would be null. Then after R pointer would point to what? My node 1. And node 1 address is where? In M, or you can say use L because both are same in our case. So you can update this with M or L. Fine or not? Then after what you can change, you also need to update this part. Here they have to point to where? They have to point our new node. So this link part address would be updated in the case of insertion. Fine. Now our L pointer. L pointer should have the address of new because new is my first node. So यहाँ पे आपको क्या लिखना पड़ेगा? 104. It is a general scenario where you want to add leftmost insertion. But in our case, we don't want to insert at leftmost because our M or L are not same. You can see L is 103 and M is 106. So what you need, you require the fifth step. Fifth step says, what is the fifth step? Fifth step says you need to update your, here you have your X, here is 104. So your left pointer should be pointed by what? It is going to be pointed by M left pointer. M is 106. So 106 have the left pointer 103. So you should write here 103. Then after you should write what? यहाँ पे आपको क्या होना चाहिए? 106. And here this location and this location need to be updated. L pointer of M, L pointer of L should be updated with your 104 and your new left right. When I say new left right means 104, fourth left position is 103. So come to the 103 and 103's R pointer is 106. So this part need to be changed with your 104. Fine or not? Why this much updation and this much operation is required? Because you have two nodes and in between you want to add something. You have two nodes, yes or no? And in between, if you want to insert something, what thing need to be changed? This is my new, yes. And in between, if you want to add, first of all, you need to update this value. यहाँ पे और यहाँ पे आपको क्या रखना है? First of all, right now in the original linked list, this is the pointer they have, yes. But when it is been inserted in between, this pointer should not point this, but instead of that, let me change the color. Instead of that, this pointer should point to the my next node, and instead of that, I just delete this link part. और क्या करना चाहिए? My this link should point to the this. So for deletion, updation of this group, am I clear to all or not? That here pointer should point to this location and this pointer need to point to this location. Fine. And after doing copy part, this this location and this location updated with the address of new, because these two pointer need to point here. Fine. Am I clear to all? Try to trace that in your book and you will get more idea about this 4 step. Let me continue with the next. Now our next operation is deletion. When I say deletion means here one memory address is already been given, that is old, and from old address need to be deleted. So how can you delete a new? So first of all you want to check that do your linked list have the that any node or not. If linked list is empty, how can you check if R or L pointer have the value null? In that case, you can say linked list is empty. No need to find the node. So return from the first step. And if first condition is false, in that case, you just have to modify one thing. What you need to do? Pay attention here. You have this is the linked list, and now what thing you need to update? Consider the scenario when you have X, Y, and Z. Now, if Y need to be deleted, what thing you have to change? First of all, you need to change the R pointer of your X and L pointer of your Z. Yes or no? And this value have Z, and this L pointer of Z should be updated with X. Yes or no? Why it would be the case? Because we want to delete our Y. So in deletion part, these two operations need to be performed. Yes or no? Now, in normal case, if L and R are pointing to the single node, L or R are pointing to the same location, in that case, our linked list has only one memory address. Yes, and if that node need to be deleted, what you can do? You just have to put L or R as a null. Now this and this location need to be updated with null because the only one node which is same as old, so you have to delete that memory location. Yes, so that is the first operation. And if that would not be the case, your linked list is not have only one node, they have more than one node. In the case that if old is matched with your L, that means whatever you want to delete is the first node. This is the first node and that node need to be deleted. What thing you have to change? Your L pointer need to be updated. Yes or no? L pointer would be updated with what? Two things you want to delete. First of all, L pointer need to be deleted on, or your left pointer of your Y need to be updated, and that is updated with the null because it become my first node and now their L pointer would be null. These two operations you need to be performed. Fine or not? Yes or no? So first what I need to what change they do, they update the L pointer and now it is not pointing to this node, now it is pointing to this node, and their left pointer is not updated with null. This is the step you have to do if you want to delete the first node. Then after, if it is the last node, if it is a rightmost node, means it is a last node, in that case you can, what you can do, you just update your R pointer. It is the R pointer which is pointing to my last node, but in the case of that you want to update that position with the help of your L pointer. L pointer give me the address of your second last node. That second last node need to be pointed by our R, and that second last node R pointer become null because it is have nothing to point and it become my last node, and this node need to be deleted. Likewise, you have to check for leftmost as well as rightmost, and if it is not a case, that it is a middle node. Yes, so in the middle node what you can do, you need to check that, you need to process that old pointer, L pointer, R pointer. What do you mean by old pointer, L pointer, R pointer? Consider the case right here. Old pointer have 106, so 106 left pointer is pointing to 103, so jump to the 103. Now 103's R pointer is where? Here. Yes or no? So this thing need to be updated. Fine or not? Find the location where updation is needed. Here the location where updation is needed, and this value would be updated with what? Old right pointer. Old is pointing to 106. 106 R pointer is 105. So this modify value is now 105. So B last R pointer is 105. So 105 have the value M. So now it becomes string DM instead of DJM. J part has been deleted. Now my string would be DM. Fine or not? And what the other operation you need to perform? Old, right, left. When I say old, right, left means what? You are at 106. 106, R pointer is pointing to 105. So 105 L pointer would be 106. So this location need to be updated with what? This location updated with your left of old. Left of old is 103. Fine or not? So it says M L part is 103 and D right part is 105. So both way it is updated. So these two operations are same as these two line. Fine. Now whatever node is there, we want to free that node and we return the L. L is the pointer which point to the first location for this video lecture.